As we saw in the previous video, we can create some type of collection that grows in size by using arrays. Now, we didn't go into a full implementation because in C Sharp, there's actually built-in classes that we can use that accomplish those goals. But they're implemented similarly to what we were doing. So what we're going to be looking at in this video is the list class. So list is a generic class. As you can see, it says system collections generic. We have a section all about generics we'll talk about in more detail. But for now, just think that generics allows us to specify the data type that we're going to use with this list. And we'll talk about this more. So let me just go ahead and create a list for you and show you how it works. So I'll say list, then in angle brackets, I put the data type. So I'll say int. So I want a list of integers. I'll call this my list equals new list of integers. Now notice that when I create this that I don't specify a size. That's because I don't have to. This will automatically grow as needed. And how this happens behind the scenes is it creates an array with a small size. And then as I call the add methods, so you can see there's an add method, and I add a number to it, if I keep on calling add and the array gets full that's under the covers, it will just create a new array and copy the values over just like what we did in the previous video. The only difference is that this list class has way more code and way more features. If I say mylist dot, as you can see, there's tons of methods and functionality that I can use with this that if I didn't use this class, yes, I could make it on my own, but it would take a lot of time and that's just not important. So I could just keep on adding as many values as I want. There's no control here, and this will, like I said, create arrays for me behind the scenes. Now, there's a bunch of methods that you can go and explore on your own. I'm not going to go through them all, but just some of the really common ones. We have add, we have remove. So there's a bunch of removes. I can remove a specific item like 50, and this will remove the first occurrence of it. I can remove all items that match a certain predicate. I can remove at a certain position. So if I say remove at, I can say remove at, the second position. I have also, remove range. This allows me to remove a starting position and how many I want to do. So you can use these, you can mess around with these. But what I want to show you is how we loop through this. So just like an array, we can use a for loop, we can use a for each loop. So for example, let's say that we wanted just to print out all the values of this list. So I'll do it the for loop first. I could say for int I equals 0 as long as I is less than my list dot count. So we use count instead of length with the list. I plus plus. Lists support indexers, so I can go console.writeLine my list sub I. Just like an array, there's no difference at all. And if I run this program, you'll see it displays my list. Now, you can also use a for each loop. So for each int I, I'll say j in my list. That also works. Now, before I move on to the next video, I want to just point out really quickly performance. Now, once again, this is kind of approaching the computer science topics, but I want you just to start thinking about performance on data structures. And I'm going to just raise some questions with you. So, if you think about it, since the internals of a list are using arrays, and every single time the array is full, it creates a brand new array and copies everything over. As you can imagine, if you were adding tons of items, like imagine for example, I was calling add a million times. That means that my list is going to be creating like tons of arrays over and over and over that will need to be garbage collected, and there's a lot of maintenance and memory problems with this. And even besides the memory problem, there's also a problem with performance. right? Every time we create a new array, we have to copy over all the values, and that takes some time. It takes unnecessary extra time. So, you have to understand when you should use each of these tools. And we'll go through more and more tools throughout this section. But one of my professors in college described it that way. Each data structure is a tool that you can use in your toolbox. And you have to understand what tool is what tool you should use for that job. Because each tool has pros and cons, right? For example, if I was trying to hammer a nail into the wall, I could, in theory, take a screwdriver and just keep on hitting it and banging it until it goes in, and that would work, but it's not as efficient as taking a hammer and doing it. And the same thing applies to all of our tools that we'll be using in these upcoming videos. So, the rule of thumb when using a list is this: lists are great when you need what's called random access. So, this right here is random access, being able to just access on the fly any elements, right? I could say my list sub 2, and I can just get the value of whatever is in there. Having that random access is powerful if you need that, and lists are great at doing that. Where the lists should not be used are in situations where you know you're going to be adding a lot of values to it over time. So, if you know you're adding thousands or hundreds of thousands of items to this list, you should probably not use a list and maybe use what's called a linked list, which we'll talk about in the next video. So, there's pros and cons.